Solving quadratics by factoring. In the first example, a equals 1, and you'll notice that y has been set to 0 so that we can find the two x-intercepts. So factoring, we're going to find two numbers that multiply to 12 and add up to 7. And in this case, that would be 3 and 4. The middle term is also positive, so it's positive 3 and positive 4. We're going to set each side to 0, so x plus 3 equals 0, or x plus 4 equals 0. Therefore, x equals negative 3, or x equals negative 4. So we've got a negative 3 and a negative 4. So the whole point of this is to find out algebraically where those two x-intercepts are. In the second example, a does not equal 1. I'm going to tidy up my equation first. So it's 2x squared, bring the 5 across, it becomes negative, bring the 1 across, subtract it from the 3, and I get 2. You have no choice, it has to be 2x and x as your factors. Now we need two numbers that multiply to 2, but they give us a negative 5 in the center. It can be 2 and 1, in which case I'll get 2 and 2. And there's no way I can make a 5 with that, so 2 and 1 is not the choice. My other choice is 1 and 2. It's negative 5 in the middle, positive on the outside, so two negatives. This will give me negative 1 and negative 4. So I successfully factored. And now I'll set each side to 0. So 2 minus 1 equals 0. Or x minus 2 equals 0. 2x equals 1. Divide both sides by 2. And x equals 1/2. On the other side, x equals 2. So I've got positive 1/2 and positive 2. And again, the whole point is to find the two x-intercepts. In this case, c equals 0. Remember, I've got everything in standard form, which is ax squared plus bx plus c. So in this case, I have no value for c. So I'm going to go ahead and factor. The only thing I can do is take out the greatest common denominator, which is x, and I'm left with 3x plus 5. Set both sides to 0. So 3x equals negative 5, and x equals negative 5 over 3. You can sometimes, if you're fluent enough, just go directly to x equals negative 5/3. And again, it is the two x-intercepts. In my next example, there's no middle term, b equals 0. The first rule of factoring is to take out the greatest common factor. In this case, it's 2. And you're left with the difference of squares inside your bracket. The 2 will disappear if you divide both sides by 2. Difference of squares, square root the first term, square root the second, add, subtract. First bracket equals 0, or the second bracket must equal 0. Therefore, x equals negative 3, or x equals 3. And again, equidistant from the axis of symmetry. Now, dealing with a little bit more of a complex equation, I've got some fractions. When you see a fraction, the first thing you instinctively should do is clear it, in which case I'm going to use 6 to clear my fractions. Multiply each term by 6. Don't forget the 2 on the other side. Treat each term exactly the same. these 6's will cancel out and become 1. 6 divided by 3 is 2. And so now I've got x squared. 2 times negative 4 is negative 8x equals negative 12. Bring it across, it becomes positive. Factor. 2 numbers that multiply to 12 but add up to negative 8, which would be negative 6 and negative 2. Set each side to 0. And your two factors are 6 and 2. And again, one more time, you are finding the x-intercepts. Our next example, perfect square trinomial. X squared minus 6s plus 9 factors easily to x minus 3 squared equals 0. There are two factors here, and they're both the same. So it's x minus 3 and x minus 3. Set both sides to 0. And you'll get two identical real roots. So they're both sitting there. That's also your axis of symmetry. Now, if it happens to not be factorable, you can use the quadratic formula. Thank you for listening.